Hello everyone, this is a video lecture for Calculus 3, section 14.2, limits. So limits are pretty interesting because we've seen them back in, say, Cal1. It's been a long time, but I'm not going to go way back to the basics of limits. Here I'm going to assume you know some of that stuff, but I'm also going to show you the new how to use it in 3 dimensions, and well, 2 and 3 dimensions, honestly, both of those. So it's going to be a little different, but I'm going to be doing stuff like L'Hopital's rule. A lot of times I'll just plug it in and see what happens, and I'm also going to teach you some new techniques, okay? So, not going over the basics, again, just because I figure you already know those. So, how limits work in... Let's go with 2D land for just a minute. And I'm going to make up my nice little cubic. And let's say I'm going for that point right there. So for limits, I'm approaching that point from both the left and the right. And that's where you get that whole limit as x approaches, I don't know, let's call it 2. Approaches 2 from the left. Limit as x approaches 2 from the right, etc. You know what I mean? Of f of x. So this is all 2D land. You're doing it from both sides, okay? So that's your 2D. In 3D land, it's kind of a little different. Actually, it's a lot different. What I have here is a domain graph. If you remember from the last section, we were graphing domains. And so in reality, we got a 3-dimensional object, x, y, z, but let's say z is equal to ln of 16 minus x squared minus y squared, something kind of like that. Again, you're going to have this domain restriction. So this is a domain, and it could actually be like all real numbers or something like that. It's not in that particular ln case, but this is a domain graph. This is your x and y, which are getting fed into the f to make your z values, okay? So just like I had x values are a domain here, now I've actually got x and y all put together. So it is still, it's 3D, it's just I'm not showing you the height. I'm just showing you the number line, I guess you can call this, or the flat plane, the xy plane that eventually has a graph coming out at z. So this is my xy plane. Anyways, so I pick a point on there, kind of like I did 2. I don't know, let's call that 2 comma 2. Doesn't matter. And you're saying, well, I've got to come in from all of the 4, I guess the 4 cardinal or like compass directions, north, south, east, west, that kind of thing. Yeah, but what about the 45-degree lines? What about, 100 and... I'm sorry, that would be 210 degrees. What about 30 degrees? What about negative 45? All these different angles that you can approach it. So just like we did, you're approaching it from both sides. Here in 3D, you're approaching it from all sides, okay? Because it's now literally encompassing every single angle that could happen. And just as a side note, let's just say that I have a point where the domain exists for all of this area here. Like basically all of this chunk here, we got arrows coming in, everything's good, we're getting numbers, but one little guy and the whole thing doesn't work anymore. It's kind of like on a 2D graph where you just have it coming up to a sharp point and then it comes down. I mean, there's a limit there, so maybe I should just not make a sharp point. I should make a break, something like that. My limit here might work, and that might work there, but they're not the same. So here even, we might have problems, okay? So you got to watch every side, okay? Now, how do you test literally every side? Do you go from 0 degrees all the way to 360 degrees, and hopefully you'll hit them all up? But, like, so from 1, 2, 3, 4 degrees, 5 degrees, 10 degrees... What about like 1.1 degrees? What about 1.0001 degrees? I mean, there's an infinite amount of answers, and so we can't actually test every side like that. We'll have to not do it manually. We'll have to be doing it conceptually. And so how do you do this? How do you see this style? Well, let me show you with my first problem. 14,205. This does not require you to go this way. In fact, the book will tell you, oh, you just needed to plug in these other things and it'll be fine. I don't want to go that way. I want to teach you the correct way first. And if there's a hard one where we can just kind of toss a number in, I'll do that as well eventually. So this is the true way you should be doing this stuff. We got x comma y is going towards 0 comma 0. Notice that we have a point, not just a number, but a point that we're approaching of x to the fourth minus 26y squared all over x squared plus 13y squared. I'm telling you, this is a doozy of a first problem, but that's okay. So how does this work? What do we do to make this thing work properly? Let me give you some old formulas from pre-cal. Here we go. X equals r cosine theta and y equals r sine theta. Now just pause for a second here. Why am I using trig all of a sudden, right? Well, remember what I was saying. I'm trying to come in from all sides, and I reference those degrees very often. That's how I'm approaching this point, is I'm thinking of it like different degrees from a unit circle. I'm thinking of it like I want to test all of my angles, okay? All of my angles. So it's just a concept, and again, you don't have to do this on every problem, but I highly recommend doing it as soon as possible to learn the process. So we have these x's and y's, which I will literally be plugging in here, okay? Now, when I do that, it'll just be a big hot mess. I get it, but there's going to be a lot of canceling, and there's going to be a concept, which I'll show you in a minute. But I can't leave this as x, y goes to 0, 0. What does it look like? Well, 0, 0 is right there, and again, I'm trying to come in from every single angle possible, right? So instead, think of it like a unit circle, and I'm wanting to make my unit circle smaller. Wow, those are bad. Let me start over. I'm trying to make my unit circle smaller and smaller and smaller until I am literally right on top of it. If you were to graph a single point here, and I want this graph in polar mode, polar form, how do you graph 0, 0 in rectangular? How do you graph that in polar? Well, it's kind of funny. It's r equals 0. R equals 0 says that there's no radius. You're sitting right there at the center. I'm asking what's theta equal to? Well, it doesn't matter because, again, your 0 radius, you're not going to be making a circle. Therefore, this limit is changed to be simply r goes to 0. This is a good thing for us because now you're working with a single variable instead of multiple variables. So let me start replacing all my x's and y's. I got r to the fourth cosine to the fourth theta minus 26 r squared sine squared theta. I got r squared cosine squared. Don't worry, it's all going to be a lot better here in a minute. 13r squared sine squared. And now I need to start figuring this thing out and simplifying it. One objection that might come up from y'all, in at least your mind, it certainly comes in mine, why can't I just plug the zeros in and see what happens, you know? We'll do that for a second. What do you get? 0, 0. Cool. So what do? You do L'Hopital's. Cool. How do you do that? Exactly. So you can't. Like what are you doing? You can't do it that way. Now, if you have a single variable, L'Hopital's might make sense. If you get 0 over 0, you would take a derivative with r because that's what you're taking your limit with. I don't think I'm going to have to go that route here. I don't really know if that's 100% on that one, but I'm just going to let that go and say, okay, we're just wanting to do the r's. Anyways, what do they have in common? Well, they all here at least have r squared. I know that one has a little bit more. So let me pull out an r squared and an r squared. Notice not from all of them. The numerators get an r squared pulled out. The denominators get an r squared pulled out. Leaving behind r squared cosine 4, 26, sine squared, And then we just got cosine squared, 13 sine squared. I sat at this for, well, this cancels, that's easy. I sat here for a minute, and I'm like, okay, well, how do I make this thing work? There's nothing else to do besides plug in the 0. I mean, you're going to have to do it eventually. So that makes this go away. You don't need that anymore. And you're left with this thing here. Okay. And let's just pause for a second. Let's just pause. This was my limit. It's now equal to this. And I'm wanting to know what my answer is here. What's the limit? Can I do a very basic problem right quick for you? Like basically, what's the next step? What do I do? Do I just type this thing in and we're done? Well, hold on. Let me just do another basic one and understand something. What if I got the limit goes to 0 of, I don't know, x squared plus 3, something like that. Well, you know, you plug in the 0 and you get a 3. Notice it's a number. It's like a y value here, okay? Same thing here. We're looking for a z value, okay, a z value. I want to know how high. How high is that in the end? And you're giving, like the boss here, a whole big formula. And the boss was just wanting to know how high it was. How high is that hill? And you give him a big, like, sheet of, you know, math. And you're like, that's not going to be helpful to me. Just measure how high it is. How high is this hill then? How high is it? And honestly, I don't know. You're going to put in a D&E for this answer because there's not a single answer. It's not a single answer. Kind of think of it in 2 dimensions where you have a break like this. Yeah. So when I go in 2 dimensions, I have an answer here of 2, and then I have an answer here of 3. Do I have a limit? No. No limit exists because there's 2 different numbers. Same thing here. Is this a single number all the time? Here, try theta equals 0 degrees. Try 30 degrees. Tell me if you get the same number. You won't. And that's the same thing. It's not a single number. It's all over the place. No limit exists. Okay. Now, how they did it in the very beginning for the book, they plugged in x equals 0 and then tried the limit with the y. This is okay. And then they went and did the rest of the math. This is okay, but you would have to do both, okay? And what if you did get the exact same answer here and there? Honestly, I don't know if I would trust it because you're kind of assuming here that you can just plug it in instead of approach it. It's a little bit on the hesitant side. There's a few cases that might not apply here, just in my opinion, okay? So I'm not going to go that route. I want to teach you the correct way the first time. Again, we could use this strategy on some problems, and I will eventually, but for right now, I'm going to let it go. Okay. I have the limit as x comma y approaches 0 comma 0 of xy over the square root of x squared plus y squared. Imagine for a second you plug in the 0, 0 into this. What do you get? You get 0 over 0. You'd have to use L'Hopital's. And then I don't know how to do that because I've got multiple variables. So back up. Don't do that. It's still something we need to try with the r's. So r goes to 0 of, I got r cosine theta, r sine theta, and then in the bottom, r cosine theta squared plus r sine theta. Oop, sorry. I'm going to put the square in there eventually. Anyways, what I have here in the top is an r squared cosine theta sine theta. In the bottom, I can pull out r squared from both of these and pull it out to the front as a single r because it was inside of that square root. Do you notice anything about this? Oh, I forgot one thing. Hold on. The limit is r goes to 0. There you go. Now it's official. Honestly, it's whatever. Notice one thing about this. Cosine squared plus sine squared is going to be a 1. Square root of 1 is a 1. You can also cancel out one of these r's. So you're left with r cosine theta sine theta. Time to plug in that 0, and you get 0 times blah 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 is 0. Did you get a single number? Yes. You're good. That's your answer. It was just 0. That's it. Next one. 14,2,025. The limit is x comma y approaches 0, 0. You can approach different numbers. They're just really happy about the 0, 0 right now, for some reason or another. X squared plus y squared, again, plus to 49. That's all on the inside. And then on the outside, minus 7. Yet again, plug in the 0, 0. What do you get? Well, you get 0 in the top, and then you eventually get 7 minus 7 in the bottom. Again, L'Hopital's, it doesn't work. You can't do it. Moving on to the r's yet again. And you can see why I use r, because it's very handy. It works almost every time, if not every time. And if it doesn't work... Oh, I'm going a little bit too fast. Hold on, let's talk about this. So notice that we have this guy right here. R squared is equal to x squared plus y squared. That's another one of those formulas. So that's x r squared. Same thing with this guy. So that's why I'm just replacing them very quickly without the sines and cosines, because this way it makes it a lot faster. Okay. Again, if you plugged in a 0 right now, it's not going to help you. But this is the funny part about this. Go ahead and plug in 0. And you get 0, 0, right? Which we just stated is L'Hopital's. But last time I said, well, I couldn't do it because you have multiple variables. Now you just got an r. So, like, all you need to do now is derivatives with r, and it should be fine. Like, actually, it's really simple. What's your derivative at the top? Oh, it's a 2r. What's your derivative down here? It's going to take a whole minute. So, r squared plus 49, keep the inside the same. Negative half power multiplied by the 2r, that 7 goes away. You don't need that anymore. This 2 and the half are going to cancel. It's kind of funny that these r's are also going to cancel. This square root is in the bottom, but it's already in the bottom, so it gets kicked up to the numerator. So it actually looks kind of like this guy right here. And then you can plug in your 0 finally. 2 square root of 49, which would make, that's a 7. 2 times 7 is 14, and you're done. Cool. All right, this one is a really big problem here coming up. So 14,2,029, I got the limit as x, y, z approaches 0, 0, 0. As I write this out, think about how I'm going to make this thing work. I've been using r, like the polar mode, right? So now that I got 3 variables, can I still use that same thing? And the answer is kinda. What I would say, this is what I wrote here, is that if we're going to do this, we might try spherical coordinates, which I don't think is a thing yet in this class. Like, it used to be really early on in Cal3 with the other book. Now, well, we don't see it for a while, and even then they just touch on it real quick like. So spherical coordinates are right out, because I'd have to teach a whole thing on spherical coordinates when you don't even know what those are. Let's not go that way. I'm going to go the way that the book says. It's a little unfortunate, but it will work in the end, and I'll show you what they do. So this is what the book does. And it's a good thing. Just don't think that this will be the best way every time, okay? So I got x equals 0, y equals 0. They're setting these equal to 1 and to 0. And then they're saying, well, okay, well, now the limit of z goes to 0 only. What they're kind of doing here is they're saying, okay, I know that my x and y are 0 for sure. And so it's actually right here. But it's also right here and right here and right here. They're not knowing that z is yet 0. It's not equal to 0. It's a limit going towards 0. So we're honing in towards this point here from the positive and negative z axes. Okay? So you see this is an X, this is a Y, and this is a Z. I'm coming in at this origin point from the top and the bottom. Just like as if I had some kind of other graph and I wanted to come in from both sides, I'm coming in here from both sides essentially, okay? That's what the idea is. Notice that I'm leaving a lot of stuff undone. If I'm going to come into this point, even from 2 dimensions, I'm supposed to come in from every single angle here, okay? 3 dimensions now, all of a sudden, I'm coming in from, you know, every single angle, not just on a plane, but like on top and the bottom and everything around this thing. It's a whole sphere that we're trying to approach getting to 0. I am only picking 2 directions here, okay? 2 directions out of infinite directions. You can see why this is a problem. I'm emphasizing that this is not always good. Okay, now that I've stated that, let's actually do what they're doing, and I'll show you what's going on. So we got the limit of this thing goes to 0. Again, they've already set x and y equal to 0, so we got 0. Y there makes it a 0. The x there makes that a 0. I haven't even plugged it into z equals 0. I haven't even done this limit yet. 0, 0, z to the 4. Apparently, I messed that up and made a square, so watch out for that. I put a little watch out on my paper too. What is this? Before I even plug in I guess I could plug in the 0 eventually, but beforehand, what is this guy already? Well, it's 0 over z to the 4th, which is always going to be a 0. Without me even doing the limit, I've already got an answer of 0. Okay, so that's something. And if you really, really, really wanted to apply that in there and see what's going on, you're going to get 0 over 0. You do the L'Hopital's about 4 times, right? And yeah, eventually you get 0. I mean, that's kind of a redundant step. You don't need to do that. What we got is 0. Okay, cool. Let's try it. So that was from those 2 directions. We've got 0 from both directions, essentially. Try something else. So the next logical conclusion for me is to say these guys now have my limit as y goes to 0 of this stuff. That's fine. Again, 2 directions, and, well, you got a lot more to go. And I don't think this is going to be as helpful as you think. You might even get the same answer of 0, let's say. Let's just say you get 0, and I'm pretty sure you do. If you get that, then you're thinking, oh, well, I got 0 both times, so I'm good. No, you're not. You've tried 4 directions out of infinity directions. Not good enough. What I'm going to say is I'm going to do what the book does. This is very unfortunate. I'm sorry for the confusion. Here we go. X equals x, y equals x, and z equals 0. Now, this is strange. Who would have ever thought to do this step? And so what are they actually doing on a 3-dimensional domain, essentially, here? They're saying x and y are the same, z equals 0. They're actually on this xy plane here, coming in at 45 degrees this way and this way. Yet again, it's only 2 directions. So why are they choosing this one rather than something else? Let me show you. So they're combining my x and y into a single x. So everywhere you see y, you put an x. Everywhere you see a z, you put a 0. So these are going to be x squared, 0, 0. These are now x squared, and then a 0. So here we go. I got now x squared, 0, 0, x squared, and a 0. So I have the limit, x goes to 0 of basically x squared over 2x squared. These x all cancel, you get a 1/2, you don't even need to apply the limit. We previously had 0 as an answer. Now we have half as an answer. Again, on a 2D graph, what you're doing is you're saying that you had, again, 1 and 2, let's say, 2 different values for 2 different limits, 2 different sides. It doesn't work. No limit, DNE. You need to be all the same number. Again, I don't like how they did this particularly because they only tested a couple sides, But they kind of knew that the answer would be this, therefore they're just trying to prove it, okay? If they didn't know that, well, we'd be sitting here quite a while. testing an infinite number of directions. Okay, I'm going to move on. I had to show you that one. Let's keep going. I got a capital F of x comma y is equal to xy over 6 plus e to the x minus y all in the power. And it says, where is this continuous? Where is this continuous? Remember, continuous is, even with sharp points, as long as you're not picking up your pencil from the paper, this is all continuous, okay? What would be not continuous is to have something like a reciprocal function. See, I had to pick my pen up off the paper in order to make that work, so this is not continuous. So how does this work here? What's the reciprocal function? Well, this is y equals 1 over x. Basically, I'd have a vertical asymptote that's going to break up my domain. And so how do vertical asymptotes work? That's whenever you get the bottom equal to 0. Notice we have a fraction. So let's go and test to see, hey, when is this fraction, when is this bottom here equal to 0? Think about it for a second here. We got 6, and then we got e to the whatever. What's the range of this thing is that basically it's going to keep going up. It's always positive. It never will itself even be 0. So even if, let's say, we took the limit as this goes to 0, and the limit would go to 0 eventually. It's just not ever going to equal 0. You still get a positive 6, which is never going to be 0. So this is always positive, okay, which is good. It's never denominator of 0. It's never that way. And so how do you express this? There's no vertical asymptotes. Let's go and look for other domain restrictions in case. Is there any square roots? Nope. Is there any natural logs? Nope. Nothing's going to stop me from being continuous. Therefore, it's continuous on all real numbers on the xy plane. Again, that's a double line R, and a little square means the xy plane. Last problem actually says to use the polar method to find your limit. It's funny because we've been doing that already ourselves a lot from like question number 1. So we're going to do this one also. I'm going to do this one with you. But it's no different design than what we've already seen, okay? Nothing new here. So I'm going to make this into my r goes to 0. I have r to the 5th, cosine to the 5th. And then I have r cubed, sine cubed. Here we have, well, what's this guy is actually just going to be an r squared. So that makes it a little bit faster. Still the limit goes to 0. I can factor out an r cubed, and this will be an r squared in the bottom, leaving behind r squared cosine to the 5th plus sine cubed. Whew, that's kind of strange, right? These cancel out, leaving an r, limit still. I'm bad about not writing that limit. R squared cosine to the 5th plus sine cubed. When you apply your 0 to both of these guys, no more limit now, 0 times 0 plus sine cubed doesn't really matter because you got 0 times everything. It's going to be a 0. That's your answer. And we are done with that section. If you have any questions, let me know. Thank you very much. Have a great day.